All right, so this is the second part of our factoring review. As I said in the last lecture video, this particular one is focused entirely on our special trinomials, or sometimes called special products. And we'll talk about why it has each of those names as we get through the different types of special products or special trinomials. So let's start with the first one, which is perfect square trinomials. Square trinomials. So these have two different forms that we see. The first is the form x plus y quantity squared, and the second is x minus y quantity squared. So just to give you a little bit of why these are sometimes called special products, and that's because this is the product, x plus y times x plus y, or x minus y times x minus y. Why we call them trinomials is because of their expansion. So you can think of this as it's two things. It's the special expansion of this product, or it's the special factorizations of the trinomials I'm about to write here. So x plus y quantity squared is equal to x squared plus 2xy plus y squared. Always in that format, no matter what this term and this term are. X and y in this case are placeholders. And x minus y squared is equal to x squared minus 2xy plus y squared. So you can see the only difference is this negative. So when it's a minus, this has a minus. So when you're looking at actual problems and factoring or expanding, you can guarantee which one you're working on just by seeing if there's a minus. Because if there is, it's only going to appear right here. If this term is a minus, it's neither of these. There's no if, ands, or buts about it. So let's look at a couple examples together. Let's look at factoring 4x squared minus 20x plus 25. So right off the bat, we're looking at this, and I see this minus sign, so I'm thinking x minus y quantity squared. So I'm going to write hopefully. So what we need to figure out is what is our x and what is our y. Now, this is not the same x. Remember, this x here is a placeholder. So we're looking at this term, connecting it back to this. So it should take whatever's inside and square it. So 4x squared equals 2x quantity squared. And then we look at this term, and it should be y squared, that y being whatever's inside here. So 25 equals 5 squared. So our goal, if it's going to be x minus y squared, our goal is to match the ends. These need to be perfect squares because our format in both of these is x squared and y squared, no matter which perfect square trinomial you're talking about. So if you don't have a perfect square, let's say this was 26, you can eliminate these from being your factorizations immediately. In this case, we have two perfect squares. So now the only question is, does this match up? So since we have the minus, we can kind of ignore it for now. But is 20x equal to 2x times 5 times 2? Because it should be 2 times the inside, times the x and the y insides. So 20x, does this equal, question mark, 2 times our inside is 2x and 5 respectively for x and y. And this is 2 times 4 times 5, which is 20. So yes. So that's what you check. Are these perfect squares? What are they perfect squares of? And once you figure that out, if you multiply those two things together and then times 2, do you get this middle term? And since we do, we know that this is 2x minus 5, quantity squared. So let's take a look at another example. So let's look, we'll say this was 1. So 2 now is factor 9x squared plus 42xy plus 49y squared. So we're looking at this term right here. Since it's a plus, we're already thinking x plus y quantity squared. That's the form we're thinking of. So now we look at this term here. Is this a perfect square? Yes, it's 3x quantity squared. And then we look at this term. Is this a perfect square? And the answer here is also yes, it's 7y quantity squared. And so now the only question is, does 42xy equal question mark? Doesn't quite look like a question mark, but you get the idea. Does it equal 2 times 3x times 7y? Well, 2 times 3 is 6, times 7 is 42. xy, yes it does. So our final answer then is 3x. This is a plus 7y quantity squared. And that's how we take care of special products, perfect square trinomials. Our next special product or special trinomial is the one that most people remember easiest, and that's difference of squares. Difference of squares. And this does not have two forms, this only has one form. And you'll hear me say this a lot in these lectures, but mathematicians are lazy. And what I mean by that is we name things to help us remember what they are. So a difference, that is the term, the technical term for subtraction. And squares literally refers to perfect squares. So we are subtracting two perfect squares. So the only form that this has is x squared minus y squared, which a lot of people often remember as x plus y times x minus y. So you have to have perfect squares, and you have to have a minus. If there's any other term, it's not difference of squares. So the reason why I say most people remember this one over the others is this is the easiest one of the couple that we're going to look at in this section to determine whether it is or isn't. So we're going to look at a couple examples. Factoring. So let's start with n squared minus 81. So you look at this and you go, okay, I have the minus sign, I have the two terms. Are my two terms perfect squares? Is n squared a perfect square? Yes, it's a variable squared. And then is 81 a perfect square? And the answer is yes, it's 9 squared. So this is n squared and 9 squared with a minus. We have the right form. So this is equal to n plus 9 times n minus 9. And you can kind of just jump to it that fast. That's why people tend to remember this. So let's look at another one real quick here. Let's do 25x to the fourth minus 64y to the sixth. So this one's a little bit more challenging. Are these perfect squares? So 25, most people will be able to identify, yes, that's a perfect square. And 64, again, yes, it's 8 squared. So now the question is, what about x to the fourth and y to the sixth? And for x to the fourth, remember the way that exponents work, and we'll discuss this further in detail later on in the semester. This is x squared squared again. And y to the sixth is y cubed squared again. So now we have the two squares, square and square. So this is really 5x squared squared minus 8y cubed squared. So even though this one's a little bit more complicated, we still have perfect squares. They're still separated by a minus sign, which means that this is still a difference of squares, and we can factor it to 5x squared plus 8y cubed times 5x squared minus 8y cubed. and that's our difference of squares. So again, this is the easiest one to identify quickly. You just have to check if you have two perfect squares and a minus. If you don't have a minus, you're just done. So that's the first thing you look at. If it's plus, it's not a special factorization. And then if you don't have perfect squares, it's done. So the last one is the sums and differences of cubes. And again, us lazy mathematicians, this is the addition and subtraction of perfect cubes. Easy, helping to remember us, making it easy. So there are two forms, x cubed plus y cubed, the sum of perfect cubes, and then you guessed it, x cubed minus y cubed, the differences of perfect cubes. So these have very specific factorizations. The sum is x plus y times x squared minus xy plus y squared. And the difference is x minus y times x squared plus xy plus y squared. So these are the ones that most people forget, and I'll even let you in a little secret. I forget them at times too, because you can see they are extremely similar, and especially the second part, very easy to mix up. So the sum of cubes gets the sum between the two terms, but then has this minus sign here. And the difference of two cubes gets the difference of the two terms, but then switches to a plus inside here. So I don't have a good way of helping you, giving you a trick. Like the difference of squares, we can just look for perfect squares and the subtraction sign. For sums and differences of cubes, this is one of those things where we just kind of have to remember it. The nice thing is it doesn't come up that often. It's not as common as it once was, but you still want to be able to identify these two things. There are more complicated formulas for other types of cubes, but they're extremely uncommon, and so we're not going to go into them. These are just two ones that pop up that, while you don't need to know necessarily right off the top of your head, it'll be nice to have them in the background. So we're just going to look at two quick examples here, and this will take us to the end of this lecture video. So let's factor number 1, x cubed minus 8. So this is our difference of cubes. It's got the minus sign. And I know I just said it's difference of cube, but what we're looking at is what's the perfect cubed here? Perfect cube. So 8 is 2 cubed. So our x is x, our y is 2. And so we just fill out this format. So this is x minus 2, and then times x squared plus 2x plus 2 squared, which is 4. And that's as far as it can go, because this trinomial here doesn't factor. And this becomes something that we'll need later on, a topic later on to solve. But that would be our final answer here. And then number 2, we'll do 8m cubed plus 125n to the 6th. So again, it is the 2m quantity cubed, which is the perfect cube here. 2 cubed is 8, m to the 3rd is m cubed. It's a plus, so we're thinking sums of cubes, not differences of cubes. And the perfect cube here, 125 is actually 5 cubed, and n to the 6th is n squared cubed. Because when we multiply when we raise exponents, we multiply. And so our x in our format is 2m, our y in our format is 5n squared. So we just fill out our x and our y. So 2m plus 5n squared. And I think I did not give myself enough space. Let's see if I can squeeze it in. And then it's going to be 2m squared, which is 4m squared. This one gets the minus. And then it's x times y, so 2m times 5n squared is 10. No, I need more space. So 2m plus 5n squared. We had the 4m squared minus sign, 2m, we're doing 2m times 5n squared, so 10mn squared, and then 5n squared squared is plus 25n to the fourth. And that becomes our final answer and what we have factored. So again, this sums and difference of cubes is the hardest of the three special factorizations that we look at. It's just something that we got to practice. Again, it's not something you're going to need all the time. It's just handy to have every now and then. So you'll have some practice problems on it and then homework on it so you can get some practice. But the big ones are the difference of squares and the perfect square trinomials. Those are going to pop up all the time throughout the rest of the class. And again, this is a review, so I know you saw it in the last math class, or hopefully you saw it in your last math class. I know summer is a long time, and maybe some of you, you're doing math for the first time in a few semesters. So we'll take it day by day, but difference of squares, perfect square trinomials are the most important. Sums and differences of cubes are nice little things to just have on our tool belt, so to speak. All right, that's going to take us to the end here.